So hello class, let's start with our first lesson, right? So the first thing you should do is read the first chapter of our text. That'll give a good background to what we'll be talking about today, right? The purpose of the class, obviously, is to write programs to solve problems, right? That is what we are here to do. Be able to do that successfully, we need to understand the platform on which our programs will be running, which is basically the computer, right? What are the different parts that make up computers? Specifically, how these different parts affect how well our programs will perform on this computer, whether they will be fast or slow, whether it'll eat up all your memory or it'll run just fine. How it might be using the network to communicate to sources on the internet and such, right? So in a live version of this course, I typically bring a big desktop computer and open it up. I might bring something like this and open it up, and we would kind of point to the different parts of the computer, the CPU that might be behind this fan, where the RAM or the faster memory is plugged in, where the slower memory, the hard disk drives are, and such, right? Sometimes there are graphics cards and network cards and things that are here, right? I use this because this is the easiest way to see the different parts. Today you have laptops and smaller form factor notebooks and such that don't allow you to see these parts as clearly. But today, let's for the purpose of a virtual class, let's go to Amazon. I did a search for desktop computers, and let's pick an arbitrary one and see what are the different parts that are specified. So let's click on this one. Okay, so let's look at what makes up this particular computer. It's not a desktop. It is a single form factor monitor plus computer all built in, but the parts are still the same. The first thing you notice is that there is a processor. This is the CPU. This is there to do all the calculations and all the hard work. Is the brain of the computer, right? You will be able to get faster CPUs for more memory, slower CPUs for less memory, and such, right? Skip down over here. Now then they're talking about memory, and there are two values here. There is the first value, which is a 12 gigabyte. This is the RAM. This is the faster memory that's closer to the CPU that is used to hold programs that are running in memory, right? And then there is this larger amount of memory that is the SSD drive, which is half a terabyte worth of memory. This is where your files are kept. Your pictures and your videos and stuff are stored on this. This is the permanent memory. This is the transient memory that holds parts of the program that are running. Okay. Next thing you'll see here is talking about your Wi-Fi adapter and your Ethernet, the wired adapter for your internet, right? And the third thing is the Bluetooth. So these are all communication technologies to talk to other things and other networks, right? And then there are peripherals such as speakers and the mouse and the keyboard and the webcam and such. And then obviously the last thing that I kind of glossed over is the presentation, the screen that they're talking about. So let's go back to our lecture notes and see what parts we identified. So we did talk about the CPU, which does logic computation. There's RAM memory, which is the faster memory, more expensive per gigabyte, but it's closer to the CPU. There's a larger storage memory, the hard disk, the SSD, which is much cheaper, so you can have a lot more of it, and that's what you use to store your files and videos and databases and such. Then there are the input devices, the keyboard and mouse, that are, you're typing something in, you're clicking, that's feeding data into the computer. There are output devices that is showing data coming out of the computer, which are monitors and printers. And then you obviously have your Wi-Fi, LAN, Bluetooth for communication to other devices. Okay, so that's the model of the computer. That's what we're dealing with when we write a program. You have to be aware that's what we are writing things on. Okay, moving on. So now we get to programming languages that we use to talk to the computer, right? They come in various categories in order of complexity. So they're high-level languages that we program in, such as Java that you'll do in this course. There is C++, there's Python, and other ones you might have heard about, right? That it's easier for humans to type that in and write programs. Those are converted into lower level languages called assembly languages. And then ultimately they're converted into really machine code, which is ones and zeros that the computer hardware can actually understand. For the purpose of this course, we'll mostly be talking about high-level languages, but be aware that there is some translation that happens to take your Java program to actually make it run on the hardware, right? So, right. As you might take other courses, they might go deeper into the process of changing the high-level languages to the lower-level machine codes and all the trade-offs that are implied there. Okay. Moving on, so I talked about that we'll be talking about high-level languages. So even within high-level languages, there are two categories. There are languages that are called compiled, and the languages that are interpreted. At a high level, the difference is compiled languages need to be converted by an explicit action to something that can actually run on a computer, right? So C, C++, Java, they all fall into that. And if you've done the Hello World example, you'll notice that we compile the Java program, the Java Hello World program, by using the compiler, which was javac command, to convert it into a program that could actually run. Compare that to Python or Ruby or JavaScript. These don't need to be converted. When you write the program, you can run it as is, right? Through a program called an interpreter, right? It doesn't have to be converted. So why have these two categories? And the reason is that compiling a program allows us to make the program very efficient. The compilation process gets rid of duplicates and optimizes the thing, so what's produced is very, very efficient and can run as fast as possible on the computer. Interpreted languages don't do that, so it can be slower, right? But the advantage there is that you don't have to wait for a big program to be compiled and then try it out and discover you had an error, right? You can just change the program and run it, right? But they will be less efficient. That's a trade-off. A trade-off is speed versus convenience is what we're talking about, right? And they both have place. There's plenty of jobs for Java programmers and also plenty of jobs for Python programmers. Okay. Java programs are typically used to, write bigger applications, and whereas Python programs are web applications and things that you would rapidly iterate and over. Okay. So moving on. You should have already set up your integrated development environment. This is the environment that you will use to write your programs. And the one we talk about in this course is something called Cloud9, which is a cloud-based development environment. So it's available on, if you have a browser, you can get to it and do your work, right? There are other environments such as Eclipse and other things which are not cloud-based. They're installed actually on your computer. So if you switch to a different computer, you have to install Eclipse again and to write programs. advantage of cloud-based IDEs, as they're called, is that they're available anywhere you have a browser, right? So you should have already seen that in your lesson, but they basically look like this. There's a window to do your editing. Of course, you have your folder tree, right? Then there's a terminal to actually allow you to compile the program and run the program and see the results. So those are the three main parts of it, right? I will not go into it much here, but because you would have already covered it in the other lesson. The first program that you would have already known how to write is the Hello World program, and it is the most basic program that we could write. It is a program that only has a single statement. The statement is the most basic building block of programs. Here there's a single statement to print the text hello world onto the screen, and this is the statement. And we'll get more into what the system out means and what println means and such later, but this is what we have, right? It is part of something called a method, right? And which is part of something called a class, right? A class being a top-level object, and then you can have several methods in the class. Each method can have several statements within it. We will again get more into this as we go through the course. Another thing you'll notice here is that there's this statement here which starts with // and this is a comment. This is not really part of the program. This is for us humans to see what might be happening on the program. So as you write a program and share it with other people, you would want to put plenty of comments in there so others can know what your intentions were, right? Here we also talk about building or compiling your program. Building and compiling is essentially the same terminology. So this Java is a compiled language, and use the command javac, which is the compiler, to compile a Java program that is called hello world.java. After you do this, it produces the actual executable program called hello world.class, right? And to run it, you use the command java and hello world. Notice you don't put .class in there, and it basically is running this program, right? And if you take the quizzes associated with this lesson, it'll give you an introduction to kinds of pitfalls and things that can happen while you're writing a program. You could, for example, miss ending double quotes, or you might be missing a semicolon or a curly brace, or have a typo, and the quiz will give you experience in how to detect those situations, right? We've already spoken about comments, but I'll talk about indentation. As you're writing the program, every time something is getting included in something else, we indent it 2 spaces by convention, right? And or whatever it may be. Some people use 3 spaces, others use 2 spaces. And the reason is for readability by humans. It is not used at all by computers. It's only for us to be able to visually see and read the program. And that is the purpose of indentation. That would be one of the requirements for when you're turning in your programs, is to have it be nicely indented. And when you go out in the world and get jobs as computer scientists, this will be expected in your program, so others reading your program can easily understand it. Similarly, you would want to make your comment well documented with comments inside to say what's happening. Guidelines for commenting is you want to put comments in anywhere where you're starting a new section, describe the new section. Also, if there's tricky parts of the program where it might not be intuitive what exactly you're trying to do, you would write a little comment to explain what you're doing, right? You don't want to over comment, and you also don't want to under comment. But again, we'll go more into this as the course progresses. Okay. Do watch the video for submitting a program. That'll be very useful. Okay, I will see you in the next lesson.